In this video I'm going to go over inverse Laplace, and this is going to be taking the Laplace of something but exactly backwards. We're going to start with something that has an s in it and end up with something that has a t in it. For instance, if we're given 1 over s, we know that the inverse Laplace, which is written like this, inverse Laplace of that function is going to be equal to 1, because if we take the Laplace of 1, that is equal to 1 over s. So we're never going to be given something this easy, so let me give you something that you might actually see here. For instance, if we are asked to find the inverse Laplace of 2 over s squared plus 4, what do? First thing is we go to our handy dandy sheet of Laplace transforms here, and we try to find something that's really close to this. Now we see that there's no s on top, and this looks really familiar. Looks a lot like a trigonometric function here. We see that sine of kt is equal to k over s squared plus k squared. Now we figure out, alright, our s squared and s squared match up, and our k and k squared kind of match up here. So what do we need to plug in for k to make this turn into that? We see that k right here is 2, and if we're to plug 2 into this k as well, 2 squared does equal 4. So the answer to this would in fact look like this, sine of 2t, because when we take this 2 and plug it into this formula right here that we are given, we do come up with this. So the Laplace, the inverse Laplace of 2 over s squared plus 4 is equal to sine of 2t. Okay, so this is pretty easy. The hardest thing is you have to look through your equation list and figure out what matches, and just plug in numbers. You can figure it out pretty easy. So what happens if we get something that looks like 1 over s cubed? Now we see that t to the n is equal to n factorial over s to the n plus 1. How can we get this to look like this? Okay, we'll start here with the s term. So the n has to be n plus 1. So this would originally had to have been 2. So let's make n 2. So we have 2 factorial over, let's see, s is 2 plus 1. That gives us our 3. But we have 2 up here on top instead of 1. So how do we get rid of this 2 and bring it down to a 1? Since this is t to the n, and we make n2 here to equal this bottom term. So right now we're at t to the 2, but this still isn't right because we have this up here on top instead of a 1. So what can we do with this formula to get this down to a 1? We can multiply that by 1/2, because that will bring that down to 1. So if we multiply this right here, we get 1 over s to the 3rd, and this is what we had over here. And so we take whatever our multiplication factor and we bring it over to our final formula. So this will be 1 over 2 times t squared. So the inverse Laplace of 1 over s to the 3 is going to be equal to 1/2 t squared.